Okay, class. Today we're going to be going over exponent rules. So what I want you to see is that you know most of these rules. We just haven't formally done these rules. So looking at the first one, the symbolic rule is a to the m power times a to the n equals what? Okay, you know from what we've done so far, what we did before spring break, that I should get m plus n. When I'm multiplying, I add my exponents. So looking at the numerical examples, 3 to the 4th times 3 to the 5th should give me, that's correct, 3 to the 9th. Now what about x to the 7th times x to the 9th? If I add my exponents, I'm going to get x to the 16th. And then for the last one, I'm just going to get, because that's kind of abstract, I'm going to get b to the a plus c, whatever a and c is. So that tells me my verbal description. To multiply terms that have the same basis, you can add the exponents. Now remember, I'm just going to keep going, but if you need to stop and write something down, just pause your recording. So now we have the rule of a to the n power divided by a to the n power. If I multiply exponents and I end up adding them, then when I divide, I'm going to end up, that's correct, subtracting them. So when I have 4 to the 7th over 4 to the 2nd, I'm going to subtract 7 from 2, and I'm going to get 4 to the 5th. Same thing applies here. Now the only thing different here is I'm going to get x to the negative 4th. And what do we remember that I told you on Friday before spring break? That's correct. We can never have a negative exponent. So that's really going to be 1 over x to the 4th power. So what we learned is to divide terms that have the same basis, you subtract your exponents. Now the next rule that we deal with is, what do I do when I have them inside parentheses? A to the m to the nth power. Well, what I really do is I take that m and the n, and you multiply it times each other. So in the instance where I have 3/4 to the 5th power, remember that means I have 5 3/4. So in essence, I really have 20 of those 4s, which is why I have 3 to the 20 power. So what about 5 to the negative 2nd to the 8th power? What am I going to get there? Okay, I'm going to get 5 to the negative 16th, which is 1 over 5 to the 16th. Good job. What about x to the 7th to the 3rd power? What would I get in that instance? Correct, I would get x to the 21. So what we're learning is to raise a power to another power, I have to multiply my exponents. If I'm raising a power to another power, that's real key, guys. So I really want you to notice that when I'm raising a power to another power. So now we're going to talk a little bit more about what the negative exponent means. And we talked about this before you laugh. We talked about that means that it has to be under 1, that I can't have a negative exponent, so it's going to have to move. In this case, it's going to be 1 divided by a to the nth power, which means I would take 10 to the negative 5th, and the 10 to the negative 5th would have to do what? Correct. It would have to move down, which would give me 1 over 10,000. So 5 to the negative 1st power would give me 1/5, whereas x to the negative 7th would give me 1 over x to the 7th. So in essence, it means negative means the reciprocals. Good job. So now let's look at here at me having a to the 1 over n power. Now keep in mind that your n is still going to be your base number, your exponent number. So we're going to look at that 1n being my exponent. That means I'm really going to have the square root of a to the nth. Okay, so it's the nth root per se. So in this case, my n is a 2, so it's the square root of 81, which is 9. In this case, my nth root is a 4, so it's the 4th root of 16, which would be 2. And then I have x to the 1 over 5, which is the 5th root, which would be this. So rational fraction exponents means, that's correct, roots. Okay, now let's look at the bottom half of the page. So now I have a to the m divided by n. Now there's a couple of ways that we can write that, guys. So I want you to go ahead and take this down. One way that I could write this would be the nth root of a to the m power. So go ahead and take a moment and write that down. So think about it. Look at 81. That's going to take my 3 and put my 3 where? That's correct. That 3 is my m, so it's going to go outside my a. Whereas the 2 is my what? That's correct. It's my root. So it's going to look like this. Now, just because they didn't write that 2 there, I want to make sure that it's understood. Let me try to write it right here. If I can get this to act right. I'm going to write in a different color so you can really see what I mean. There's really a 2 right here. There's a little 2. That's the square root. So that's where that 2 went. So now when I'm looking at 16 to the 3/4 power, where's the 3 going to go? Correct, outside my a. And where's the 4 going to go? It's going to be the 4th root. So if I take the 4th root of 16, I'm going to get what? Correct, 2. And 2 to the 3rd power will give me 8. And I'm going to do the same thing for my x. I know that was a little bit tricky, but if you practice with that, you'll really understand it. And don't worry, we'll do lots of practicing. So for fraction exponents, the numerator is a power, where the denominator is a root. So now let's look at the last exponent rule. If a of n equals to a of m, then we know that n has to equal m. So sometimes we're not going to even deal with bases. If my bases are the same, I can just deal with my exponents. So in this case, I have base 5 to the 2x minus 1 power equals 5 to the 7th power. Well, because I know that my bases are the same, they're both base 5, I can ignore my 5 and I can solve for my powers, which is 2x minus 1 equals 7. And I would just solve that like a regular equation. In this case, I take my 1 over, I would get 8, and 8 divided by 2 is 4. Now let's look at this next one. My bases are not the same, correct? So I have to make them have a common base, because I know that 3 to the what power is 9? That's correct, 2. So I can take into account that 3 to the 2. You see what we did here? So I changed that 9 to 3 to the 2. So now I can rewrite that by distributing it and getting 3 to the 2x minus 6 equals 3 to the 4th. So now my bases are the same, so I can ignore my bases and focus on my exponents. So I know that 2x minus 6 is going to equal 4, and then I'm going to just solve that equation, and I'm going to end up with x equals 5. So you can solve for variables in exponential equations if both sides have a common base. Okay, I did really good here. Now we're going to do some practicing so that you can really solidify this concept right here. And I have faith that you will. So enjoy the rest of your day. Or if we're in class right now, it's time to get to work. Talk to you later. Bye.